Good morning everyone. Welcome to the problem number 2 homework portal week 6. So this problem is more focused on mechanics. This is especially for the IB1 students. Okay, now let us begin with this. This problem is for 10 marks, so I have allotted 10 minutes to solve this problem. Let us see whether we can do it within the time. Okay, let me start the timer. Right. So a glider is an aircraft with no engine. To be launched, a glider is uniformly accelerated. Uniformly accelerated, which means what? Equations of motion can be used. From rest, which means what? Initial velocity is equal to 0. By a cable pulled by a motor that exerts a horizontal force on the glider throughout the launch. It means a constant force has been acting on it. Okay. The glider reaches its launch speed of 27 meter per second. Which velocity is this? This is your final velocity after accelerating for 11 seconds. Time is given. So what all is known to you? U is known, V is known, T is known. What all can we find from here? I have not read the full question. Okay. Before that itself, let us try to understand what is given, what can be found out from here. We can find out the value of A using the formula V minus U divided by T. We can also find out the distance to which it travels from U equal to 0, from T equal to 0 to T equal to 11 seconds using these parameters, which is U plus V divided by 2 multiplied by T, average velocity multiplied by time, which you can use it whenever the acceleration is constant. Okay, now after this, assume that the glider moves horizontally until it leaves the ground. Calculate the total distance traveled by the glider before it leaves the ground. Total distance, this one, right, as I told you. So you can use S equal to U plus V divided by 2 multiplied by T, which should be U is 0, V is 27 divided by 2 multiplied by 11. Okay, let us calculate what is this value. So this should be 27 divided by 2. Just a minute, I made a mistake. 27 divided by 2 is equal to so much, multiplied by 11 will be 148.5. So the answer is 148.5. What is the unit meter over here? Now look at this here. There are two significant figures. Here it is 4. So what I should do? I should reduce this to 2. So how do I reduce? Round this and write it as 150 meters is your final answer. Okay. Next, the glider and the pilot have a total mass is given. During the acceleration, the glider is subjected to have an average resistive force 160 Newton. So what's happening over here? The glider is moving like this, okay, but there is a resistive force acting like this, which is 160 Newton, right? And then what else he says? Determine the average tension in the cable as the glider accelerates. So if the glider has been pulled in this direction. So now this problem amounts to something like this. See, this is your mass glider with the pilot, and this is your cord which has been pulled over here, and there is a resistive force which has been given over here. Resistive force, which is Fr, which is given here as 160 Newton, and as a result of it, now it is experiencing an acceleration. What is the average tension has been asked, and then he says there is an acceleration. Acceleration is A over here. How do I find the value of A? A can be found out using V minus U divided by T. What is V? V is nothing but 27 meter per second. U is 0. I told you already. You can use this. So 27 minus 0 divided by T. T is 11 seconds. So how much do I get? 27 by 11. 27 by 11 is equal to 2.45. 2.45 meter per second square. This is your acceleration you get. Now what we do is, let us write down the equation. I can now write T minus 160 is equal to M into A. What is M here? M is 492. So I will write this as 492 multiplied by 2.45. Right? So therefore the value of T should be 160 plus 492 multiplied by 2.45. When I do this, how much do I get? So I have this 2.45 multiplied by 492 is equal to so much plus 160. I made a mistake here. Let me do it once again. So 492 multiplied by 2.45 plus 160 is equal to 1365. So you get the answer here as 1365. T is Newton over here. This is the answer for this. Okay, are we right? This answer is 1365 Newton. Okay, so closer to 1370 Newton I got. Okay, fine. Next question. What's the next question? The cable is pulled by an motor, electric motor. The motor has an overall efficiency of 23%. Determine the average power input to the motor. Power input is been asked. So what is efficiency? Efficiency is power output by power input is equal to 0.23. 23% is 0.23. So you want to find out P input over here. P input should be equal to output power 0 divided by 0.23. Okay. Now how do I get the output power? What is power? Power is nothing but work done per unit. What is it? Work done per unit time, right? Now what is work done? Work done is equal to force into displacement divided by time. Now you see displacement by time is velocity, so I will write as a force into velocity. Now what is this force? The force which is being driven by the tension, right? So which is being tension over here. What is the tension here? We already calculated 1365 multiplied by velocity. What is the velocity that you have over here? Velocity, what is the velocity here? Let us find out what is the velocity. 150 divided by t. How do I do this? 150 divided by time is it given? Time is given here as 11 seconds, right? 11, yeah. Okay, so therefore this should be 6365 multiplied by 150, or what's the actual value? We did not take 150 here. 148.5. For calculation we use the actual value, so we don't use this one here. 148.5 divided by 11 seconds. Okay, this is your displacement, this is your time over here. So when I do this, okay, so this is your output power divided by 0.23, because I should not miss this one here. Let us do all the calculation to get the value of the input power. So I get this as 1365 multiplied by 148.5 divided by 11 is equal to so much, divided by 0.23. When I do this, I get this as 80,119 watts over here. This is nearly 80.1 kilowatt. 80.1 kilowatt. Okay, what is the answer? So it is around 80.1 kilowatt. Yes. Okay, now let us move on to the next one. After takeoff, the cable is released, and the unpowered glider moves horizontally at a constant speed. Okay, the wings of the glider provides a lift force. The glider diagram shows the lift force acting on the glider and the direction of the motion of the glider. Okay, everything is given here. Draw the forces acting on the glider to complete the free body diagram. There are some forces which are missing over here. What are those? That's the question over here. See, when the glider is going up over here, what force is acting? There is an mg force acting over here. Then there is also a resistive force acting in the backward direction. There is a resistive force acting over here. Anything else that we have? Oh, we don't have anything. Okay, so these two forces are essential to draw this. The resultant will be something like this over here. So this is your lift force. Okay, so thus we have come to an end to this problem. So we have finished it 2 minutes earlier itself. Okay, thank you. So do subscribe to my channel for more updates. So thank you once again.